This video deals with Newton's second law, which relates the acceleration imparted or achieved by an object under the influence of one or more forces acting on it. We let the vector F stand for the vector sum of all forces. You already have learned how to construct the sum of displacement vectors. There won't be anything different here. Let M be the mass of the object. I should point out that the units associated with the mass of an object is the kilogram, which is 1,000 grams. A gram, in case you're not sure, is the mass of a classic M&M candy. It takes 3 grams to make a penny. All right, back to this. The forces that we will be adding are in units of newtons, after Isaac Newton, abbreviated lowercase m, as shown here. The mass units, as I've said, are in kilograms, abbreviated kg. Let the vector A represent the acceleration that the object acquires because of the application of these forces. I show an object at the origin of a coordinate system initially. 3 forces acting on it, 100 newtons, 120 newtons, 90 newtons, and you can see at the various angles. The mass is 6 kg. In case you're curious, a kilogram is about the weight of 2 pounds. Let's work a sample problem involving these vectors. Suppose that the object that is at the origin of our coordinate system initially has an x component of velocity of 2 meters per second and a 0 y component of initial velocity. So the object will be moving because it's being pushed or pulled on. We want to know what will be the x and y coordinates. Those 2 questions need to be answered when 4 seconds have gone by. Well, you've seen the x equation in the past and the y equation, so I have nothing more to say about it. We can find the value of x if we know what v naught x is, and we do, it's 2. And if we know what t is supposed to be, and we do, it's 4 seconds. But we don't know a sub x. This will take some work. The same thing can be said about finding the y coordinate of this future location. We need v naught y, and we do, it's 0. We need a sub y. We don't know what it is. So we have these 2 questions to answer before we can answer the original question, or questions plural. What is x and what is y? So let's set about finding a sub x and a sub y. Well, Newton's second law, which I ignored earlier, is shown here. The future acceleration, or the current acceleration, of an object is equal to the total force acting on it divided by the mass of the object. I repeat that equation here. Now, if the vector A equals the vector F over m, then the x components follow a similar pattern. A sub x is F sub x over m. A sub y is F sub y over m. So we can find the values of a sub x and a sub y if we know those 2 numbers. So these 2 question marks replace these 2, and these 2 replace these 2. So working backwards, we see we'll have the answer to our question, what is x and what is y, if we can determine what fx and fy are. What's a simple matter to do that, provided you remember how to use the component method to add vectors, or if you recall how to find the x component of a vector that's a sum of several. Well, I will discuss what we would do, and then I'll show you the result. F sub x is 100 cos 30 plus 90 cos 60 minus 120 sine of 70, or 120 cosine of 20 with a negative sign because that vector casts a shadow on the negative side of the x-axis. So to repeat, for the three x components, 100 cos 30, 90 cos 60, negative 120 cos 20, or negative 120 sine 70, however you want to write it. What about the y component of the total force? It's the sum of the three separate y components, 100 sine 30 minus 90 sine 60 minus 120 sine 20, or minus 120 cos 70. Well, I'll work that out for you. So I calculated the sum of the three separate x components and the sum of the three separate y components, and obtained this result for f sub x and that result for f sub y. And so now we just work backwards until we have the values of x and y. The problem is essentially solved except for some mathematical substitutions. I write etc. here, meaning I don't have room to finish the problem on the whiteboard, but it's a simple matter for you to finish it. I may have also calculated a sub x and a sub y. Let me look. I did. A sub x, according to this equation, is f sub x divided by m. But m is 6 kg. And so from that I got 3.14 meters per second squared. And then a sub y, negative 11.5. Now you can take those two numbers and put them here to get x, and there to get y, and you then will be done.